Okay. Let me share my screen. All right, can you all see my screen?
Yes.
Minimize this. All right, see the chat. All right, let's give everybody a couple more minutes before we get started. Any questions before we get started? The quiz should still be, no, wait a minute. The assignment is due today, right? But tonight. And so today we're going to introduce the new assignments. Quick question for DB3. Does it matter if I do it on a different schema? You do it on a different schema. You mean instead of DB_design? Okay, so you created another schema for DB3. So I'm wondering if this is acceptable. Well, the problem that you might run into, let's see, maybe not. I guess it won't be an issue because we're gonna have you, right? We're gonna have you import a schema, and it'll create any schema that it'll overwrite any schema that you might have. So I guess it's not an issue. Just make a comment when you submit it. I'm not sure if our rubric keeps track of whether checking to see if the name of the schema is DB_design. I don't believe so, but yeah, I mean, I wouldn't mind. Just check with me if I don't think you're gonna lose points, but check with us, you know, if you do. All right, let's see. Welcome, Nathan. Welcome, Ali. Welcome, Kicho. Asher, Anna. Welcome, Marco and Nicholas. Giving everybody a couple more minutes. Let's see something in the chat. Can TAs have rubrics for DB3 and quiz 1? Yes, I'll make those available. All right, a couple more minutes. I'm wondering, I have here, as in the Zoom call, I have I see everybody who's logged in. I can see some of the videos, just myself and everyone else, but I'm sharing my screen. Do you see this this part of the screen of where I can see everybody? Or do you see my browser?
Just the Google browser or the Chrome.
Okay, so you don't see the Zoom windows that it opens. So because Zoom opens up a whole bunch of windows and controls, which get in the way. And I was wondering if everybody else saw it when I shared my screen.
At least right now, no. It's
No,
just
good.
the canvas.
Now I'm moving one of the Zoom controls. You don't see it? You don't see me moving?
No, not at all. Not at all.
Okay, perfect. I was worried that it was just getting in the way all the time. All right, excellent. Let's get started. So welcome. Yeah, so this is the fourth week in our database design course. Let's see, up to this point, we have been, the first week we explored how to set up a development environment that we're going to be using throughout the semester. We installed the MySQL server and the client. We then spent about a week on how to design the database in terms of coming up with a schema and the data structures, the relationships, and the data types and whatnot. Right? What is the shape of the database? We then spent all last week talking about, now that we have a design and we know what the data structure looks like, how do we actually implement it in a relational database, right? So we spent a week on using the create statement, SQL create statement, to create the tables and the relationships between those tables, foreign keys, primary keys, right, cascade deletes and things like that, of establishing what the structure of the data is and how the relationships were going to be implemented. Now, this week we're going to be spending a time using that database we just created last week. Okay, so what we're going to do is that I'm going to provide you with the with a database that will be pretty much the solution to last week's assignment, and so you can use that for the upcoming assignment, right? You're going to be able to, it's going to be populated with data, and then we're going to ask you to query that data, right? So that you can retrieve data from the database. So we created the database. It's a little more involved than what we had you work in the previous week. We added a couple more tables, a couple more relationships, and then we populated the data with records in each one of the tables. Okay, and so this week you're going to play around with that table. Tables, right? You're going to import that database into your schema, right? With all the data that's already in there. And then we're going to ask you to query some of that data. So we'll go over the assignment first, and we'll demo some of the queries, right? Following the same strategy that we've had for the last couple of assignments, where we first demonstrate us doing something, and then we ask you to accomplish something similar to that on your own. Okay, but using the demonstration as a basis, as a guide to accomplish the task. We're then going to come back and revisit and formally introduce many of the topics and the queries that we're going to be using in the assignment. We're going to be covering it for the remainder of the week, starting with SQL queries. We'll talk about subqueries. We'll talk about group by, and so on for the remainder of the week. All right. All right, so that's the plan for this week. And also there'll be a quiz again towards the end of the week on Friday. And there'll be quiz number 2, which will be on the topic that we covered last week, right? So last week was about creating the database, right? And you had a chance to play around with all that work, and then there'll be a quiz on creating the database that you worked on last week. Okay. All right. Any questions before we get started? All right. Let's get going. Let's talk about the 4th assignment, querying the relational database. Okay. So we're going to be using the same database that we have been using for the last couple of weeks, right? We have the user, reply, blogs, rating, posts, and whatnot, right? And so we're going to learn about how do we import databases, right? In the previous assignment, we had you learn how to export a database. So in this assignment, we're going to learn how to import a database, right? We're also going to be talking about compound primary keys, enumerated data types. We're going to learn how to retrieve data using the select statement. We're going to learn how to join tables, right? So that last week we talked about relational algebra and all the different operations that you can do with relational algebra. One of the last things that we talked about was joining, right? Being able to join 2 tables which was basically a first a cross product, right, and then a select on a foreign key primary key. So we'll get a chance to play around with that today. And so first of all, we're assuming you have this database or this schema in your database. If you don't have it because you might have created a separate schema, you might have named it something different, please create the db_design and keep working based on that schema, because a lot of the instructions are based on you following a particular naming convention, a particular set of tables and whatnot, and otherwise the instructions don't work. So we're assuming in these instructions that you have a schema called db_design, and we ask you to download a database that we have exported, right? And then we're asking you to import it into your schema so that you can play around with it, right? So if I click on that, it's going to go to my GitHub account, and you can download from here. This will download it into your download folder. I'm going to click on it. It'll unzip it, and there it is, right? So in here we have definitions for different tables, right? There's a replies table, the follows table, ratings, topics, users, posts, blogs, okay? Implementing the relational database for that. Let's see on the chat. If we use a different schema for our homework, should we go back and change our queries to use db_design instead? I'm not sure how is that going to affect the grading. I don't believe so. I don't believe it's going to affect. Although obviously the TAs, if they have data they can play around with, all your queries won't work, right? Because they will have the schema in front of the queries. So there's two choices, right? Either go ahead and change your schema and change all your queries, or from your queries, if you remove the schema name from your queries, right? Because all your select statements or your if you remove the name of the schema in front of the statements, right, it's going to use the default schema, right? So that if the TAs double click on their own schema, your queries or your SQL statements, if they don't have the name of the schema in front, right, then they will work just fine in the TA's database. Okay, but if you provide the schema, it doesn't work. The TAs are going to have to go in there and remove those schemas themselves manually, right? And so that's going to just make everything a little bit slower in the grading process. So if you could at least remove the name of the schema in front of all your SQL statements, right, so that it'll work in any schema, right? Any default schema will work. Okay, and from now on we're going to be giving you the database which is already populated, and so you can just stick to the database that we give you from now on, right? Okay, so there it is. So these are the tables, and each one of the tables has data in there. So for instance, if I double click on users, did it open? No. Actually, let me open it. Open with, I guess, MySQL. Yeah. There it is. So this is the data that we exported, and includes the recreation of the tables, right? It drops the table, it recreates the table, and then it populates the table with data. It inserts Alice, it inserts Bob, it inserts Tim, it inserts Elon, it inserts Charlie Brown, it inserts Daniel Craig. So it inserts a whole bunch of users into the users table, right? So it recreates the table for us, okay? Which is great, right? So let's do that. So the assignment asks you to do that first, right? It asks you to import, and you unzip the folder we just unzipped, right? And to import the data, you go to Workbench, and from the main menu, you go to Server Data Import. So let's do that. So we go to Server Data Import. Hello? Oh, I'm not connected, sorry. Let's select a database connection. Okay, so Server Data Import. Okay, there we go. And then you select this tab, the Import from Disk. You select the Import from Dump Project folder, and you can then navigate to the folder where you unzipped. And we unzipped it on the downloads. There it is. That's the folder I'm going to select. I'm going to say Open, and you can then click on Start Import. You click on Start Import, and it's going to recreate all the data. So any data that you might have had already in there is going to be clobbered. Okay, so if you want to save any data that you had already in there, you're going to have to dump it somewhere else, right? You're going to have to export it elsewhere if you want to keep any of that information, and then you can bring the data back. Yeah, so now in the design, if you refresh, right, you should have the tables that we created, including a couple of new tables like topics and topics and replies. I think that's follows, right? So that's another table that you did not have, right? So those two tables are also in there, and you can look at some of the information in there. You can look at the users. So there we have Alice, Bob, Tim, Elon, Charlie, and Daniel, right? You have a couple of posts. We have a couple of replies. We have a couple of topics, right, with cars and space. Okay, we have a couple of people following each other. Okay, I guess one person following, right? So you can peruse through some of that through some of that data. Okay. All right. So now that it's imported, we ask you to do a couple of things. So first of all, we're going to do really simple stuff, right? Where we're going to ask you to select all the records from a table. So you might have done this already, right? That's simple. So in a new query string, in a new query, first of all, let's double click on the database, right? So that it becomes the default one, so that all these commands, they they work against the default database, right? So it's going to work against these DB design, right? And then you can just select, and run it, right? And it comes back with all the users. There it is, perfect, right? So we ask you to do that, and to to make sure that the list that all the users come out in the query, in the result grid. Okay. And also notice that we put a comment on top of the query. It's a good practice, right, to always add a small little blurb comment on all your queries. So we ask you to please do the same thing. We also ask you to make sure that all your statements end with a semicolon, right? And if you're going to have a lot of select statements, which you will have a lot of select statements one after another, to please add a space or a new line between the queries. Okay, separate them with at least one new line. Other than that, you're going to have this. All your queries are going to be in this one screen, and you're going to save it. You're going to save it, and the name we ask you to call it is the querying relational databases, right? So save it somewhere. I'm going to save it into downloads, and then just keep working in this same file. Okay, you're going to have a bunch of select statements, and then the TA is going to use this, to validate and grade you. Okay. All right. So once we've done that, we ask you to now try it, right, in the same SQL screen, a couple lines below, right? Retrieve all the records from the blog table, right? Retrieve all the records from the blog table, right? So basically, it's just this, right, with this says blogs, right? And then you run it, and there's our blogs, right? So you do that. You're gonna do that, right? All right. So that's the first part. Save all your work. Okay. Also, we ask you to always put a comment. Implement and comment. Notice comments are useful. Confirm, blah blah blah, and we ask you to comment everything you do. All right. So now instead of retrieving all of them, we ask you to retrieve a single record, right, by its primary key. right? So for instance, let's retrieve a particular blog if we know its primary key, and we can take a look at all the blogs, right? We can look at all the blogs, and we're being asked to retrieve the blog whose ID is 2. So this one, I think, right? So we can just copy that, right? Let's bring it to our file, paste that, and we're going to execute only that one. And there it is, right? There's a blog by Everyday Astronaut, the Tim Dodd, the Everyday Astronaut, right? And it prints that out. Save it. Now we ask you to retrieve all the posts or posts whose ID is equal to 3. So that's easy, right? You can just use this as a guide, and you just change the ID to 3. Now it says retrieving records by a particular criteria. Right, so for instance, this one retrieves the queries, retrieves a user whose username is Elon, right? So let's run that, and there it is. Elon comes back, and then we ask you to do it. You do it. No, so from the blogs table, retrieve the blog whose name is SpaceX. Okay, add a comment and save to the file. Then joining two tables, meaning we're going to have two tables, the blogs table and the users table, right? So the blogs table, here it is. Oh, we have it right here. Sorry, there it is, right? This one. And you have the users table. And the blogs table has a foreign key, right? This foreign key here, user, right? That is referencing the user who posted that, who owns that blog, right? And here are the users. We have Alice, we have Bob, Tim, Elon, Charlie, and Daniel. So this blog here, the Everyday Astronaut, is owned by user number 3, which is user number 3 over here, Tim Dodd, the Everyday Astronaut. These two blogs are owned by user number 4. So 4 is Elon. So Elon owns the blogs, SpaceX and Tesla. And whereas these two, Tesla Daily and Hyperchange, are owned by user number 6, Daniel Craig. So Daniel Craig owns these two blogs, right? So we're asking you to, right, in this query, is to join and retrieve the name of the blog, which is in the blogs table, and the username who owns it, which is the user table. So we need to go fetch some information from the user table, some information from the blog, and then join it together, right? So let's do that. So if we grab that and we paste that in here, and then we run it, right, that comes back with, there they are. See, these are all the users, and these are the blogs owned by those users. Okay, excellent. And then we ask you to do it on your own. Right? So now you try it. Write a SQL code that will retrieve the blog names and the related posts. Okay, so the names of the blogs and then the posts. Add a comment, save the SQL file. All right. Okay, so this is using what is called explicit join, right? Where you use the keyword join. Now you can this syntax is a little bit hard to read when you have to join 3 or 4 or 5 different tables, right? It becomes hard to read because you have to do it 2 at a time, right? Remember that in relational algebra, the join operator, right, took 2 tables at a time, right? And then you would need to join it with parentheses and whatnot, right? So first, for that reason, there is a alternative syntax that accomplishes exactly the same thing that we did over here, but instead of using the join, right, it uses the where keyword. Okay, so this one says, take those 2 tables. Notice that there's no join keyword, right? And instead, it's going to do the join with this where clause, meaning I only want those records between users and blogs. Right? So this does the cross product. This does the cross product and considers all the users with all the blogs. But this one filters and says, well, I don't want all of them. I only want the ones whose blogs user matches the user ID. Okay, so let's grab this, right, and let's copy it. Let's put it at the bottom. And if we run it, we should get exactly the same information that we had earlier. There it is, same thing. right? Username and the name of the blog. Okay, so no difference. The result set should be the result grid should be exactly the same. So we ask you to do the same thing. You're using this technique, right? Rewrite the query that we asked you to do before. Rewrite it in such a way that you don't use the join keyword, right? You do it with the implicit. You do an implicit join. Okay. All right. So let's keep going. So you can combine in the where clause, right? You can have in the where clause, these are called predicates, right? Things that need to be true, right? So for instance, I want the users and blogs, but not all of them, only the ones where this is true, right? Where this predicate is true. Yes? So in the where clause, you can have many predicates. Here's a predicate, right? The ones that match, right? The users that match the blogs. And you can have other predicates that you can combine with Boolean expressions, right? And, or, and, right? And you can use parentheses to organize that. Let's see a question in the chat. When it says related posts, is it asking for the class post or the attribute post? Oh, good call. The attribute. All right, so let's put that here. The and related and the posts of in the related records in the posts table. Okay, and the posts and the related records in the post table. Okay, that makes more sense maybe. Yeah, so you can put in the where clause, you can put any number of predicates, right, that you can then combine using the and the ors and not, right? You can use parentheses to create all sorts of complex Boolean expressions. Okay. Well, here's two predicates. One that does the join between the two tables, and here's another predicate, right? I only want out of those blogs and users, I only want to keep the ones where the username is Elon, right? So meaning out of all these, which are come back as there's 5, I only want to really keep these two, right? So I'm going to rewrite this, and so basically what I've done is that into the previous query, I've added this and, right? So I'm adding an additional filter, right? So if I run this, notice that I only really get those 2. So I am filtering out all the other ones that I don't want. I only want to keep the ones by Elon. Okay. All right. How about 3 tables, right? So for instance, the user. If you remember, there's a relationship between the user to the blog and then to blog to the post. So we're going to join these 3 tables: user, blog, and post. Right. Let's do that. And what we're going to try and do is, these are the 3 tables that we're going to be joining. We want to extract the user from the user table. We're going to grab the blog from the blog, the name of the blog, and then we want to extract the actual post, right, from the post, right, and all from Tim Dodd's, the Everyday Astronaut. All right, so let's grab that. And I mean, you can see here user, blog, and if we look at the posts, right, notice that user Tim Dodd is this one right here, number 3, right? And blogs, we have just this one blog. See that? And so there's only one record that matches from between users and blogs. So Everyday Astronaut has only just one blog. And then posts, in order, the blog is number 2. The ID is number 2. So in the post, we really only care about the post for blog number 2. So this is the only one. Wait, SpaceX stinks? Tim Dodd said that? All right, so let's join that. Let's join all 3 queries, right? So let's put that in there. Let's run that. And yeah, okay, so Everyday Astronaut posted two posts. Can we all just stop and admire for a second? Blah 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 blah. Has a tiki bar at the MK1's flaps. Okay. Yeah, so those are the posts for those blogs for that username. Okay. All right, excellent. And then so we ask you to do the same thing. Join 3 tables where between the blog, the posts, and the replies, right, to those posts, whose blog name is equal to Everyday Astronaut. So find all the posts with the blog names, the posts, and the replies. Okay. Then aggregating. So aggregating. When we looked at relational algebra, we saw that one of the operations was that we could group by. Well, we can group multiple records, right, and we can aggregate them, right? We can add them. We can do the averages. We can do minimum, maximums. We can count them, right? So here's an example where we're going to grab the ratings table. We're going to grab the ratings table, and we're going to group by the ratings, the post ID. So we want to look at the ratings table has references to the post, right? And says that, and then it collects per post, right? It collects how many ratings there are, right? How many likes there were. So that's what we're going to do, right? So if you look at the ratings table, okay, so we have the ratings table says this user 3 liked this post, okay, whereas this user 4 didn't like this post. See that, right? This user, oh God, actually no, this user we don't have any here, right? What else? Yeah, so we also have that somebody give it a score 3, 4, 5, 5. We don't know who though. We don't have information about the user. Right? So, but we have likes and we have scores. Likes and we have scores. And it turns out the likes is a Boolean, right? So this is true, false, right? True, false. Okay. And so we want to count how many likes there are for a given post. So for instance, this is post 1, 2, so this is post 1, 1, 1, 1 has received, let's see, has received 1 like, has received another like, and then a not like, so a thumbs down, right, a false. So we want to count how many total likes there were, right? How about post number 2 here, post number 2, right, has received 3 likes, 2 unlikes, and then another like. So we would like to maybe find out how many times have somebody liked something, right? So we can do that with this query. We can say, okay, well, group by the ID of the post ID. So we're going to group by this post ID, right? So notice that we just have 2 posts, 1 and 2. So we're going to have 2 groups, 1 group for post 1 and 1 group for post 2. And what we're going to do is that once we have these 2 groups, within those groups, we're going to add up all the likes, right? Add up all the likes, right? So for group number 2, we're going to add up, that's 0. Number 2 here, we have another 1, 2, 3, 4. So it should come out to 4. And for group 1, there should be 1, 2, 3, right? And then that's it, 3. So 3 and 4. Okay, so let's run that. Let's see. Let's run that. There we go. So for post number 1, we got 3 likes, and for post number 2, we got 4 likes. Yes. All right, excellent. So we say, okay, great. So you've done it. We've shown you how to do it. Now we ask you to do something a little more challenging. Using the same ratings table, we want you to average out the scores. Okay, meaning, right, if you go back to the ratings for the same posts, which there's only 2 posts, so there's only 2 groups, we want to average out all the scores. See the scores? So notice that for post number 1, I don't have a score over here. So here either for post number 1, here either. But over here, I do have a score of 3. Here I have a group of 4, a 5, a 5, and then for post number 2, I have 4, 4, 5, 4, 3. So you're going to aggregate for group number 1, which is post number 1. You're going to average out all these values. All right, these are for number 1, so it's 3 plus 4 plus 5 plus 5, divided by 4. But just there's an average function. There's an average. There's an AVG aggregation function. So you're going to use AVG instead of sum. Okay. Right, for the scores. You're gonna be averaging out scores, not likes. Okay. All right. So let's keep going. Then we're going to ask you to use inline views. So inline views is a capability is a feature where you can embed a select statement inside of another select statement. So basically, here you have the from clause. Yes, the from allows you to tell what tables are you looking at, right? And up to this point, we've been using 3, 1 table, 2 tables, 3 tables. Well, those tables, right? You can also, instead of a table, you can take the output of a select statement. Remember in relational algebra, we could nest operations, right? That the output of an operation can be used as an input for an outer operation. Remember that, right? So the product could be used for the join for a select, right? And then for that it could be a projection, right? So a product, select, and then projection, right? So same thing here, right? So the output of this select, which happens to be what? Happens to be the previous one. It happens to be this one. See that? The one we gave you earlier. So we're using that, right? That comes back with what? It comes back with, where'd it go? With this. There it is. So notice that this looks very much like a table, doesn't it? Right? Just like if I do a query of all the posts, right? Right. These are all the posts and these are all the blogs, right? And that's the table of the blogs table. Well, this query right here returns something that looks very much like a table. It's not a table, obviously, right? It's a result grid. It's a result set, right? A set of rows that comes back that we calculated. It's not stored in the database, right? This is the output of that query. Well, we can use that output as an input to another query, right? So it can treat that, because this looks like a table, we can treat it as if it were an actual table. So that's exactly what we're doing here. We're grabbing the previous query here, and we're using it as the input as if it were a table. So this from, which usually only works with tables, the third item here is a table. I mean, it's going to treat it as a table, and we're going to, since it's not a real table, we need to give it a name, right? A temporary name, and whatever that comes back with, because blogs and posts are actual tables and they have actual names. And so we're going to name this table. It's a virtual table, right? It only exists as far as this query is concerned. We're going to give it a name of inline view. So inline view is a very common technique, right? That you can nest, queries inside of other queries, right? And they're called, formally, they're called inline views. So this select statement is referred to as an inline view. So that's why I chose the name inline view. You can call it whatever you want. But it'll be treated, in any case, it'll be treated like a table, as if it were just a table. So when you do the query, outside there would be a where clause and says, well, now that I have the views and the likes and whatnot, right? The results is going to come back with the post IDs. It's going to come back with the ratings, right? So the post IDs and the ratings, right? It's in there. Well, I want to join the post ID with the actual post table, right? And I want to join the blogs with the blogs ID, and then so I can now extract the blog, the post, and how many likes. So I want to know, the query is that I want to know the blog, the post, and the likes. Okay, so let's grab that. Let's paste that and let's run that. There. So this is the same information that we had earlier, but this was a little bit too cryptic, right? This was a little bit too cryptic. Right? So that just numbers, right? And numbers really don't mean anything to me. So I'm going to join it with the actual blog, the actual post, and fetch the actual name of the blog and the post where this like or dislike occurred, right? So we can do that. There's our 3 and 4 from before, the same 3 and 4, but now we know what blog had happened and what was the actual post. Okay. Now we ask you to do something similar. We ask you to say, okay, well, now use the query you wrote earlier, right, that you used for average, so for calculating the average, right, and create an inline view, the above view, and retrieve the blogs, the posts, and the inline aggregate score. Okay. All right. So at the end, you're going to end up with a file like this, right? That's going to have about 50 lines of the query that we're going to give you, and then another 50 lines of SQL that was written by you. All right, and all in the same file, And what the TAs are going to do, right? They're going to go and validate. This is going to run it, right? Going to run one at a time and check to see that it does what it's supposed to do. Okay. All right, excellent. So that's the assignment DB3. Any questions? All right, excellent. Let's keep going then. All right, so SQL queries. Let's talk about SQL queries. All right, so the last week we introduced relational algebra, right? And it was the theoretical foundation for what we're going to be covering, for the next several weeks, right? For about a month or so, right? So the syntax that we're going to be using is part of a language called structured query language, right? And it was it was an attempt at grabbing a lot of the theoretical foundations, design that designed all this idea on how is that we're going to interact with the databases, and says, okay, well, let's actually write a database, right? That you can write these queries in a semi kind of looking English-like language, right? That implements a lot of the same ideas that were introduced in the relational algebra theoretical foundation. Okay, so SQL, or structured query language, it was written in it's designed so that it's a low bar of entry for folks who are not necessarily programmers, could still perhaps create some useful queries and retrieve data from the database, right? Because one of the challenges is that not only to store the large amounts of data, but then to retrieve that information for processing by us. Okay, and so here's the most basic type of query, right? Where you have a select statement and you have a from statement, right? Clause. You have a select clause and you have a from clause. That's the most basic one. Okay. And I guess I should add here. Where, and these are predicates. Okay, that's the most basic one, right? Now, if you try to translate this into relational algebra, you'll see that you have here the keyword select, right? So this is straight from relational algebra. The fields that you want is basically a projection, right? It says, you're going to go fetching all sorts of fields and records from the table, but I only want these subfields. So this is basically a projection. The from clause, if it's a single table, then it's just a table, right? But if you have multiple tables here, table 1, table 2, table 3, then that's a product, right? You are doing a cross product of all those tables and calculating all the possible combinations. But then in the where clause, right, this is your select algebra, relational algebra, where you provide a predicate that says, well, I only want these sub rows. I don't want all of them. I don't want all of the ones that were joined, but I only want the ones that meet a certain criteria. So basically, this is several statements, several relational algebra statements, all written in a pseudo English way. Okay. And so the queries, what it does is that it extracts data from a potentially large set of tables, right? That might be multiple tables, multiple records. It could be thousands, tens of thousands, millions of records, right? Into a collation, right? Into an aggregation of a single result set, right? That might contain a subset of the rows, a subset of the columns, right? Maybe some aggregations, right? Into a single view, right? So we are going to be using this database that we started off at the beginning of the semester, right? Where we have multiple students. We have 9 students. We have 3 departments. We have 6 courses across 5 sections, and these are the enrollments of the student enrolled in a particular section, okay, and the grade they got. So all the queries that we're going to be looking at are based on this database. Okay, so here's an example, right? So here's an example where we are retrieving from a particular table, from student, okay, and then the select. Now this is a kind of like a projection, and so this is only a projection that says, okay, from the student table, I only want to project the student name and the graduation year. Notice that there's no select here, right, per se, in a relational algebra sense, right? Because there's no where clause, right? There's no predicate, meaning I want the entire table. I want the entire table, but I don't want all the columns, right? So I want the entire table, but I only want 2 of the columns that are in the student table. Yes, notice that there's no where clause, so there is no select per se, right? So you're retrieving the entire table, okay? Also notice that we are prefixing the fields with the table name, right? We're saying that this is the student name that appears in the student table and the graduation year in the student table. Now, here it's not necessary, right, to prefix it because it is unambiguous that these fields exist in the student table that is listed here. Now, you would only need to prefix the field that you want only if there is an ambiguity, right, where you might have multiple tables using the same exact field name, right? But if there's no ambiguity, then you don't need to put you don't need to prefix the field that you're retrieving. Okay. You can also, right, if your table that you have in the from clause is fairly long or complex or cryptic, okay, it might have some weird name because we want to save the number of characters, right? So it might have a cryptic name. You can rename them. You can rename the tables. Okay, this is the rename. This is the rename operation that we introduced in relational algebra that allows you to rename columns, right? So there it is. So I can rename the name of the table only for the queries. Not like you're renaming the table, the actual physical table that is stored, right? You're only renaming it locally, giving it a local name, maybe some shorter name, right, for convenience purposes, right? You just say S and that's it instead of student. Too many characters to type, right? And then you can use that instead of the actual name of the table. Okay. So yeah. So if there's no ambiguity on the where this field lives, right? That you know it's in the student table, then there's no need to put the, if there's no ambiguity, there's no need to put the table name in front of it like we did here. See, we didn't put the name of the student in there or anything like that. Also, if you want all the fields, right? If you want all the fields, you can just say star. So star, right, just says, well, give me all the fields, right? I'm not projecting anything, just give it to me all, right? Whereas this is a projection. You're adding the fields that you want is a projection, or you can just say, I want all of them. You can also say that if you have another table, so you have table B, right? You can and you call it EWQ, right? You can retrieve two fields from the student table, and I might say that I want all the fields from table EWQ. Okay, you can do that as well, right? But let me remove that. There we go. Wait a minute. Was there something else here? Oh, okay. All right. All right. So here's an example, right, where we have these two tables, and we have the department table, and we have the employee table, and presumably there is a foreign key, primary key between these two, right? So, for instance, this DID, presumably it's a foreign key. This is a foreign key, right? And this is a primary key, presumably. Okay. And DID is referencing this ID over here, right? And now, because DID, we know that lives inside of employee, and we know ID lives inside of department, but because they don't have the same name, right, then there's no need to put the name of the table in front of these, because D name is a department name and the name is the name of the employee. There's no ambiguity, and so you don't have to put the department name in front of the field. But say this would have been name here and name. Now you would have something like this: the name of the employee and the name of the department. Now there's a collision. It says, wait a minute, I have two fields that have the same name in two different tables. Which one do you mean? Well, then in that case, you would have to put department, right, and employee in front of the table, right, to explain which one do you want from which table. Okay. But because we have D name, then it's not an issue. Okay. All right, so here's a couple of examples of doing some simple select statements here, where you have the persons. We have the persons table, right, that has Alice and Bob and Charlie at different addresses, right? And we are retrieving all the persons, so it returns the entire table. Basically, is this whole thing, right? Plus maybe several others. Or over here, we are only retrieving last name and first name from the person. So the entire table, but only the columns last name and first name. Okay. You can also use what it's called a distinct keyword, right? That when it returns the values, right? You can put distinct in front of a column and say, make sure, right, when the results come back, that particular column has distinct values, right? So for instance, in this case where you select all the cities from person, right, it retrieves all the cities, right, even including people that might live in the same city. So the result would contain duplicates, right, of the city. But I can use the distinct keyword, right, in front of a field, and then it would only return the unique values. All right, so types. So in if you remember when we created the tables, right, we gave every field, we gave it a data type, right? Some of them were integers, some of them were dates, and some of them were tiny ints. Well, SQL provides a broad plethora of data types for declaring your all your fields, and just here's a few, right? But there's tons of them, so I'm not gonna go over them, right? So there's just way too many. Varchar, okay, and each one of them has different operations that you can work on them, right? So for instance, you can concatenate strings, you can do date manipulation, right? If on date data type, you can do arithmetic with numeric data types. Yes. Now you should always check with the vendor, right? The final folks who sell you the database. What are the actual functions and operations that you can do, right? Also, many of these data types, you can provide the size or the maximum size that they can be, and if you, and they're very strict. So if you try to store a piece of information that is bigger than what that data type allows, right, any of that information is going to be truncated. So you have to be careful, right? So here's just a few of the functions. I mean, I'm not going to go through all of them. There's just way too many. But I'm just going to introduce just a few that might be useful to you, and definitely check out the documentation for MySQL or whatever database you end up using. So for instance, here are a couple of string operations, being able to convert strings to a lowercase or uppercase, right? Or trim, so that you take out any leading spaces or any trailing spaces. You can calculate the length of a string. You can do substring, right? Very much like in Java or C#, right? Where if you're giving a long string, you can retrieve a subset of that string, right, at a starting point, and then how long that string might be. You can also retrieve the current user, right? So that if I'm logged in, or you're logged in, or whatever faculty is logged in, you can do queries, based on the ID of the currently logged in. That's important because you can make queries about the courses that you might be teaching, or the sections that you're enrolled in, right? And then do queries. The same query, if I run it, it gives me something peculiar to me. But if you run it, the same query will give you something that is specific to you, right? Because it's using the current user, right? So that it's offset by whoever is logged in. The double bar, vertical bar, allows you to concatenate two strings. Like is an operator that returns a Boolean whether a pattern is found in a string. So for instance, you can say is a particular string like some other string, right? And you can use the parentheses operator, right, to do some pattern matching, which is pretty cool. So here's a couple of examples, right, where the pattern is underscore I, %I, underscore, right? So each one of these means something, right? For instance, the underscore matches a single character, right? Then the literal I, then % matches any number of characters, so 0 or more characters, okay? And then I, that's a little string I, right? And then it matches a single character, right? So notice that indeed Einstein matches this query, right? This like statement. So because E matches the underscore, then I matches the I, and then and ST, that's all the %, right? All the %, and then it hits the I, right? And this I, it matches this last one, right? And then at the end you have just N. Okay. So yeah, so the like operator can be used to, when you're iterating over many records, right, and you want to filter by a piece of text that you're looking, so that it follows a particular pattern, right? You can use like for that, right? Now like is very expensive, right? Because not only are you iterating over all the rows, but then when you look at a particular value in characters, right, you're gonna have to, it has to iterate, looking for that pattern, right? For every instance of every row. So like is extremely expensive. So here's a couple example, some documentation like the like pattern, right? What each character means, right? And you can use things that regular expressions to create your own statements like that. Just a couple more examples. Here we have a couple a couple of people in the persons table, and we want to extract folks that match the pattern of a city starting with LO, right? Like Lowell. Okay, so there we go. So it returns with 2 users, right? These 2 right here, right? And it drops out the Drake record. All right, so data types, the SQL also supports a plethora of formats that represent dates, right? The standard date format is 4 digits for the year, 2 digits for the month, and 1 digit and 2 digits for the day, all separated by dashes, right? And you can create a new date, right, by using the keyword date, right, and then providing the pattern, right, which maps to whatever meaning that is. Okay. You can also calculate an interval. You can say, well, how many weeks or how many months, how many years, right? Are certain things apart. If you give it 2 dates, it'll give you an interval. You can subtract them. You can multiply. You can add them. You can do all sorts of math operation on dates, right? And you have to be careful. All these operations are different vendors implementing slightly different ways. So make sure that you become familiar with whatever vendor you end up using. But here's just a couple of the functions that are available. Just like this current user, there's also current date, right? So you can give a timestamp of when something occurred right now. You can giving a date, you can extract or break apart the dates, right? So that you can extract months, years, days, right? Perhaps from the result of having done some kind of operation where you can maybe add or subtract between dates, between intervals. Given a date, you can add an interval like weeks, months, right? So you can say, if you're giving a starting date plus interval 7 months, right? It comes back with a resulting date, right? So it does very nice. It takes care of holidays. It takes care of business days. It takes care of leap years, right? So it's very, very powerful, right? It knows what it's running in what part of the world. So it'll apply, the rules of that particular region, right? So very, very powerful. Date format, this is just only to point out that there are many date formats, and it's not particularly standard across the vendors, right? So different vendors implement it different ways. So again, you have to check your vendor for the official documentation. Here's just a few MySQL functions that are available for your needs. I'm just making this a little bigger. And the SQL Server declares its own thing. Okay, has a different set of date functions. Here's just an example on using SQL Server's date functions, right? Where you can use get the date, right? And you can see that it prints out in military format. You can convert it into a character, right? The first part, which is just the short version of the date, right? And so these are just formats. There's 1, 101, 2, 102. So these are formats that are specific to MySQL. I mean, Microsoft's SQL Server, right? That knows how to format that date as a string, right? In a particular format, and so that you can format it in military format, in European format, where you have year, month, day, right? Where or using periods, or using full-blown years, whatnot. So again, this is very SQL Server oriented, right? So this documentation, you would need to check it, right, with whatever vendor you end up using. All right, so let's play around a little bit with the select clause, which we briefly introduced in the previous couple of examples. Let's take a look at this, right? In particular, we're going to take a look at being able to generate or extend, right? Remember that in relational algebra examples that we saw at the end of last week, we saw that we can generate columns on the fly, right, with values that were calculated. Like, for instance, the example that we looked at was the full name, right? Full name is a column that normally you would not store in your schema, right? Because it has dependencies with other fields, right? And we saw that that's a no-no, right? That breaks third normal form, right? That if you have a field dependent on other fields, that's a no-no, right? So we don't do that. We don't want to do that. But we can query the data, and we can totally, generate that field on the fly, like full name, which basically will be the concatenation of first name with last name. Okay. So let's take a look. Let's just play around with this, right? So for instance, we're selecting everything from the students table, so all the fields, but I am going to add an additional field here, which is called grad class. And the way I create the new field, which is extend, right? It's the relational algebra extend operation. But this is implemented using SQL syntax. So as graduation class allows you to say, okay, well, I'm going to create a new field that's going to be called grad class, and its value is going to be calculated as follows. I'm going to subtract, right, the current graduation year for the student. I'm going to subtract the year for which the college was founded, right? So if I subtract that, I'll know that certain people are from the first graduation, second graduation, third graduation, right? If you graduated in 1864, and and if I subtract 1863, well, you are the number one, the first graduating class, right? So this generates a brand new result set with a new column that was not there before, right? It was not part of the original table. I also am creating a brand new column right next to at the end, right? A new column called college, which is going to add hard-coded value there, which is BC, right? Perhaps Boston College or something. Okay. So there it is. So here's an example on what the output is. So these two columns were not there before, right? And this is just these are being calculated on the fly. Now the actual data that is stored in the database is here on the left-hand side, but not this. So this is not in the database, right? We are creating that as we go. All right, so another example, here's a simple select statement that returns from the student table, it returns the student ID, the name, and the graduation year. That's it. This totally works, right? And it retrieves those three fields from the students, right? And it returns the entire table, right? We're not filtering anything, right? It returns the entire table. But I am going to rename a couple of things. So SID, I'm going to rename it as another field called new SID, right? Whereas the graduation year, right, or graduation decade, I want to, from the year, I want to calculate what graduation decade are you, right? So if, for instance, if you are in, if you're 2003, then you are in the first decade, right? If you're 2014, you are in the second decade, and so on and so forth, right? So let's see how we can do that. And so there it is. So what we do is that we're going to create, we're going to take the value, the old ID of the students. We're going to concatenate it. There's the double bar. We're going to concatenate the string student ID or student number, right? We're going to concatenate the value of the student ID, right? And we're going to create a brand new field called new SID, okay? And that's it for now, right? For the graduating class, for the graduating decade, right? We're going to use the following calculation, right? We're going to grab your graduation year, right? Say it's 2013, yes, and we're going to divide it by 10. So it becomes 201.3, yes, 201.3. We're going to cast it into an integer, so that becomes just 201, and then we're going to multiply by 10, so it becomes 2010, right? So you are of the decade of the 2010 decade, right? Because if you follow 2011, 12, 13, 14, 15, right, all the way up to 2019, right, you're going to fall within that decade. So you're the decade of 2010, and we are building, renaming that field. We're going to call it graduation decade. All right. So here's an example, right, of Joe, Amy, and whatnot, right, having graduated in the decade of the 2000s. All right. All right. So here's a couple of more advanced features, right? You can use, as it's iterating over the records, right? You can use functions such as case, when, and then, right? That allows you to calculate fields, based on other fields, right? So for instance, you can say, as it's iterating over this simple table, A contains values 1, 2, 3, right? We can look at the value of A and check to see the values, if it's 1, if it's 2, if it's 3, and against several conditions. And if those conditions are met, right, we can say, all right, well, then when this happens, right, then I want to do something. I want to calculate. I want to return a value, or otherwise just return some default value. So let's just show you a really quick example. Here it is, right? We're going to do a select A. So select A just returns just a simple record, a field 1, 2, 3, right? The second one, the second part of the select statement, right? There's a case, right, that checks the value of A against a particular value of 1, right? So this 1 here, if A is equal to 1, then I'm going to output the string 1, right? If it's equal to 2, then I'm going to output the value 2. If it's greater than 3, right? Well, if it's 3 or greater, right, then I'm going to return other. So basically, you end up with this, right? Here's A with 1, 2, 3, and the case, coming back with these calculated values, right? Pretty cool. Now there's another version of this. There's another version here. This is a very powerful syntax, right? This is very much like your switch case statement in other programming languages, but this one's a little more powerful, right? Because this is more like nested if statements, right? In the nested if statements, each if has its own predicate. Is this true? And if it's true, then you evaluate the then clause, right? Whereas the switch statement is more like this one, where you have a single expression, and depending on that, the result of that expression, it gets compared against certain possible values, and then you calculate the result, right? So this is a little bit less powerful, right? Because you only get one expression, and it gets compared against all these constants, right? As opposed to having independent predicates. All right, we looked at that already. All right, so let's do some more. We can, here's another example, right? We are selecting from the students table. We are extracting from the year. This is the graduation year, right? You're going to extract the current date, right? So date is the day, right? And then we're going to be subtracting the graduation year, right? And we're going to check to see whether you are an alum, right? Whether you're an alumni, right? Or are you still in school? So basically, what we want to do I'm sorry. Current date is today. Is the date for today, right? And so we want to extract the year from the current date. So this year is 2021, and we want to compare it against when the student is going to graduate, right? So this is all in one. This is all in one line, right? Like that. Okay. So we want to compare, right? We want to look at we want to calculate, how far is the current date from when you're going to graduate. Yes. Now, if the graduation date is in the future, then you are still you're still in school, right? You're still enrolled, right? But if the graduation year is in the past, that means that you've already graduated, so you're an alumni. Okay. So yeah. So for instance, if it's 2011, the graduate gives you 2011, right? And if you're going to graduate in 2007, it gives you a 4, right? Subtract 2011 minus 2007 is 4. That means that you still have to graduate, right? That oh, wait a minute, 2000 current date, 2011. Okay, that means, okay, this is greater than 0, means that the graduation year is in the past, right? So that you're an alumni, right? If it's still in the future, then this will give you 0 or negative value. Okay, that means that you're still in school. All right. So let's take a look at this, right? So we can use an example of using case, right, where we can check to see the alumni years, right? If it's greater than 0, then then you're an alumni, you've graduated. If not, if it's negative, that means that you have yet to graduate. Okay, which is pretty cool. Now, some folks might find the case syntax a little bit hard to read. So there is an if version of it, which looks very much like the Excel spreadsheet if, where it checks to see the predicate. Is this true? If it's true, it evaluates the first argument. If it's not true, it evaluates the second argument. Okay. All right, so let's play around with the from clause. Let's look at the from clause. All right, so yeah, we've been using the from clause, right? But let's revisit it a little bit. Right? Remember that I had hinted at the fact that the from clause basically does a product, right? It does a cross product between the tables, considering all the possible combinations, right? Because to implement this, you're going to have to iterate over the outer table and then iterate over the inner table, right? And that basically creates a nested loop that is going to consider all the possible combinations of records of one table with all the records in the other table, right? Yeah. So as we mentioned earlier, we can name or rename the tables, right, by adding an alias. These are called aliases, right? You can alias the table. This is not only convenient, if the table is cryptic or has a very long name and you want to shorten it. Not only is it convenient that way, but it's also convenient or necessary when you're doing self joins, right? Where you're doing a query where the two tables that you're trying to join are actually the same table, right? And you would say, well, why would you ever want to do that? Well, for instance, imagine you had an employee table, right? An employee table where you have employees, right? Regular employees, but then you might have certain managers, right? And those managers might be at different levels, right? They might be just a development manager. Then you have a senior manager that manages many managers, and then you have a VP, right, that manages multiple directors, right? And so you have your manager, director, and your VP, CEO. So you have a whole bunch of employees that are working for each other, right? And this creates a hierarchy where you have at the root, you have the board of directors, right? And then you have the CEO under that, and then you have the president, VP, blah blah blah, and all the way down to the employees, right? So this hierarchy is basically, since they're all employees, they are all in the employee table. So imagine you want to create, hey, I want to know who's working for John, right? And so you need to join employees in the employee table with John, which is also an employee, right? So if you're joining two tables that have the same name, right, and you want to extract the name of the, say, the manager and the name of the employee, which both are first name and last name, you need to be able to disambiguate this, right? And say, well, they're called the same. What do I do? So you can rename them. So not only can you rename tables, you can also rename the fields, right, when they are displayed in the result grid, right? Name 1 and name 2. Now, this is going to be very, very useful when we talk about self joins a little later. Combining tables, right? If you have records that are on one table and you have records that are in a different table, and you want to be able to retrieve data from one table and retrieve from another table, right? And we want to do it when these two are related somehow, right? Where the foreign key in one of the tables matches the primary key in another table, right? So to do that, we introduced in relational algebra, we introduced the join, right? Remember, the join was the combination of doing first a cross product with a select, yes, and the select filtered only the subset that actually was a relationship between the two records. So the way you do that in SQL is that you use the from clause and you grab the two tables, right, and then you join them. So that creates the cross product, okay? But then you don't want all of them. So you're going to filter out. You're only going to keep the ones where the foreign key of one of the tables might match the primary key of the other table, right? And then here you have a projection where you might only want to keep the name of the student and the name of the department, okay? So let's go back to this syntax, right? Where you have here, right? You have the selecting all the columns, right? Where you joining two tables, table 1 with table 2, and then the on just puts in the foreign key primary key relationships between the two records. Yes. Now, depending on how you use this join, right? It has different names in the industry. Now, the most common one that we're going to be using throughout the semester is called the inner join, or just plain old join, right? Or sometimes referred to as the natural join. Natural join, inner join, join, right? They all mean the same thing. Basically, typically what it means is that you do a join on some predicate which relates records in one table with records in another table, which usually it's implemented using a foreign key primary key. Okay, all right. Now, there are other types of joins that we mentioned briefly in relational algebra. We call it the outer join, right? Which brings records, right? So the join only retrieves records that are related to one another, right? So it throws away any records that are not related, okay, which makes sense. But sometimes, not often, sometimes you want to bring in records that did not match, okay, and so one of the options is that, well, we have records on so when it comes back, the join, it comes back with those records from both table A and table B, or table 1 and table 2, right? That matched, right? That have a reference between them, right? Now, there were a whole bunch of records in table 1 that didn't match any records from table 2, right? So what do you do with those records? Usually you ignore them because they're not related. Who cares? But sometimes, right, it makes sense that you want those records that didn't match anyway. Even if they didn't match, I still want them. Bring them over, okay? That's where the outer join comes in, right? The outer join. So a full outer join means, well, I want everything. I want not only the ones that matched, I want even the records that didn't match. Just bring in everything. And that's very expensive. You know, you're going to bring in, you know, tons of records that have nothing to do with each other, right? So oftentimes you either, instead of using a full outer join, the more common that folks use is that you want a left or right outer join, right? And what that means is that you know, I want the join, the normal join, the inner join, right, natural join of the records that match. Plus, also bring me the records that didn't match from the left table, and this is the table. Like table 1 here is on the left of the join keyword. See that? And table 2 here is on the right of the join keyword. See that? So you can say, well, I want a left outer join, meaning if there are records in table 1 that don't match, bring them in anyway. Or I can say a right outer join. It means that, well, first bring me all the records that do match, plus bring me the records from the right table that didn't match. I want those too. Okay. Now, why would you ever want to do that, right? So let's go through each one of them, right? Look at some examples, right? So here we have two tables, right? So here's we have the persons table, and we have Boone, we have Dole, Garcia, right? And we have orders. And there's a relationship between these two, right? Notice that this is a primary key, presumably, and this is a foreign key that is relating to these primary keys, right? And there are 2 foreign keys for 3, and there are 2 foreign keys for 1, and for some reason, somehow, this has a foreign key of 15 that doesn't reference anything on the other table. Yes? I don't know how that happened, but yes, we have an orphan. We have an orphan. So yeah, so if you do the join, if you do the inner join, here it is, right? We are going to join. Let me make this a little bit easier to read. Oops, that's worse. There we go. So basically we're saying join these 2 tables, right? The person table and the order table. That means that it's going to find, right, that I'm going to match these 3 with this one. I'm going to match this one with this one, and I'm not going to be able to match this one, right? This last one. So it basically comes back with all the records that matched. There they are, right? The 4 that matched. Okay, which is basically what you would expect. Everybody good? All right, so let's take a look at, oops, oh no, the jump. Sorry, I think that's where we were. Yeah, right here. This is where we were. Yeah, so this is the natural understanding of what we're going to be doing mostly. The most queries are going to look like this, right? We're going to join 2 tables on a primary key, foreign key, and that's it. Okay. Now let's take a look at the left join. Right. So the left join is saying, here's table 1, which is on my left, right? It's the left on the left of my join, and here's my table on the right. Okay. So this is going to do is going to first do a natural join between A and B, table 1 and 2, plus is going to return the data from table 1 to table 1 on my left that didn't match. So let's take a look at the original data, right? And check out the data here that it's not going to match. You know, in this case, what do we have? We have that data in the order table, 15 has no match with the table above, right? So if I do a left join, notice what's happening is that even though Dole Garcia, right, had no orders whatsoever, okay, because there was no foreign key on the order that matched Bob Dole, nevertheless, I'm going to bring in the records from the user because it's on the left, this person, see that? It's on the left. So I'm going to bring in even the records that didn't match. Obviously, I'm not going to have an order for them. That's why they were not in the natural join in the first place, right? Because there was no matching, but I want them anyway. Or you might say, you might ask, well, why would you even do that, right? If they're not matched, if there's no match, why would you even bring in the records? Where here's an example. Here's an example of where this would apply, right? Here's a very good example. So here you have staff, right, that they work, at a company at the university, say, and they have spouses, right? Husband, wife, whatever, right? And each person has a social security number, but the spouse also has a foreign key, right, that references the staff. It references their husband or wife, right, which is a staff at the organization. Yes. Okay. So you understand the structure of the data, right? So yeah. So here we have spouse ESSN references staff SSN. Okay. Well, what if you have the following query, right? Find the name of each staff member, right, and her spouse, right? Say the query ended here, it ended there, right? So what you would do is that you would join staff and spouse, and the join would be on the student, on the SSN and the ESSN, and that's what you get, right? You get the staff and their spouse, yes, and you call it a day. You're done, right? You're done. But say I want to invite all my staff, at the party, the end of year party, and I say, well, invite also your significant other, right? So what does that entail? What query is that? The query would be, well, okay, find all the spouses, all the staff, right, and make the invitation. Please, dear Mr. and Mrs. Annunziato, come, blah 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 blah. Well, what happens to those folks that are not married? Right? You're not going to invite them, right? Are you not going to generate an invite for those folks, right? So that's where in this case, right, you might have in your query, you might have something like, find the name of each staff member and her spouse, if any. That means that if they don't have the spouse, I still want to know who the staff is, regardless of whether they actually have a join with some other table, right? I want their name because I want to generate the invitation anyway. Okay, so you would do the regular way, right? You would do just grab the staff name and also the spouse name, and you would do the join normally, right, on the foreign key equals the parent key. But this is going to filter out folks that are not married. You can say, oh, you're not going to invite people that are not married. So to fix that, you instead would use left join, right? Meaning I am also going to invite those folks that are not married, even the ones that don't have a join, right? They don't have a natural join. I want to bring those staff, invite them, even though I'm not going to have a spouse name and a spouse last name because they're not married. Okay, so this is an example where you would want to use left join or right join and whatnot. Right join has exactly the same syntax, but the data that you are retrieving is from the right table as opposed to the left table. Obviously, if you swap the tables around, then you would they would be completely equivalent to each other. So here's another example, right, where we do using the same exact database from before, and where we're going to join these two. If you remember that some of these had no reference to each other, like 15 has no references to any person. And so when you do a right join, right, you see that I'm going to generate the data from the order, even though it has no match on the person. Okay. All right. All right. Okay. How about a full join? So a full join returns everything, right? Returns not only the data that that is related to each other, but also records that are not don't have anything to do with each other, right? So here is returning all first the inner join, then is returning the left join, and then is returning the right join. Okay, so it's returning everything. Now, what if you want to specify multiple joins, right? Maybe you want to join data between the student table and the enrollment table, and you know that the student ID and the SID of each one of the tables match. So here's a join on those two, but then you want to join that with another table, like with a section. Well, to do that, you use parentheses, right? So where you join two tables at a time, right? So you join two tables, and the result of that, you're going to join, right, on another foreign key, primary key, right, between those, right? And then you can create, multiple nested joins. Now, this writing this can get fairly hard to read, right? It's going to be pretty hard to read. So there is an alternative syntax called implicit notation, right? So there's the explicit notation, uses the join department on and then the primary key foreign key, right? So join uses the join key. Now there is an implicit notation that doesn't use the join keyword, right? Where you just give it the tables that you want to join, and then the predicate that you used on the on clause here, you can use it here on the where clause, right? You can use it on the where clause. We haven't introduced the where clause just yet, so that's a great segue to introduce now the where clause. Let's talk about the where clause, right? So the where clause is where you put, up to this point, right, we have been retrieving the entire table because we haven't had a where clause, right? Well, maybe not the whole table, because when you join, right, you only retrieve the records that match each other, right? But now the where clause is going to allow us to filter even further, right, and provide predicates that allow you to filter based on whether those predicates are true or not, right? And you add it, at the bottom of the select from where. All right, so let's take a look at some of the operators, right? So basically, what you're going to have here are going to have multiple Boolean expressions, lots of Boolean expressions that you can combine, right, using Boolean operators such as, equal, not equal, greater than, less than, between, like, in. So just a note of caution here for not equal. We use the greater than, less than symbols, right? And that means not equal, right? So that's you should remember, that key character sequence. So here's a couple of simple examples. Right here we have the person table from before, and then we are retrieving the persons from Lowell, and there we have two folks here from Lowell, and notice that we're retrieving all the fields, so it looks exactly the same as before, right? This fields, all the fields, but only those records that meet that criteria, where the city is equal to Lowell. Okay. Now you can make the queries more interesting by combining multiple predicates, right? Using just Boolean operators such as and, or, and then you can use parentheses, right, to make ever more complex queries. So here's an example of or, and a combination of and or, again using the parentheses, right, to establish the order of operation, right? So here we're doing the or first, and then we're doing the and. Multiple joins. So the multiple joins, right? If you're using the the syntax where you use the join keyword, right, it would be fairly hard to read, right? Whereas in the implicit syntax, it's fairly simple to read, right? So let's look at an example, and we're going to be combining in the where clause some predicates that are that are operating on fields that are not keys, right? Foreign key, primary keys, right? So for instance, the graduation year, my salary, right? When I started working here, right? My date of birth, all those are non-key fields, and they are naturally, obviously, part of the where clause, right? But the where clause can also be used for joining, right? Using the implicit syntax, right? Where you can, instead of using the join keyword, right, you can put the primary key and foreign key, you can put them in the where clause. So you can make a combination, right, in the where clause where some predicates are non-key, some predicates are key, right? So let's look at a couple examples. For instance, this where clause is strictly doing a where clause on fields that are not keys, right? I want the students between the graduation year of 2005 and 2006. Graduation year is not a key, right? It's not a foreign key, it's not a primary key, right? This one over here where we're joining three tables, right? We're joining student with enrollment with section. Well, I can rewrite it with a where clause, right? Where the SID, the student ID for the student table matches the student ID in the enrollment table. And then the section ID in the enrollment table matches the section ID in the section table. Yes, right? And so this one's so much easier to read than this. This definitely is much harder to read than this over here, right? So again, we're going to use that quite often. It's very common where we're joining multiple tables together, right? Or you can also combine in the where clause, you can combine, predicates that are for joining, right? Where you can say, well, this foreign key is equal to that primary key. Combine it with predicates that are not for joining, right? That allow you to just, compare values in non-key fields, right? And the where clause allows you to combine both of them, very, very easily. Okay. Between is going to allow us to compare ranges, right? So, retrieve from me, right, all the all the grades that I got, right, between an 80 and a 90, right? Give me all those values, right? So between allows you to give you two values, and it will only return those records that are in between two values. Okay. So for instance, you can use it for lexicographical, comparing strings, right? So for instance, return all the people that are between Boone and Garcia, right? So it sorts the content alphabetically, right? And then it can compare the values of last name, right? And make sure that it meets this criteria over here. What, is this better like that? I think it's, yeah, I think that's better. Easy to read. Yeah. You can also use not between, right, which is basically the inverse, right? It says, well, give me the ones that are not in between, right? So the outer, the ones that don't have an intersection between those two sets, right? You can use the in keyword where you can provide a set of values that are going to be compared against, right? So that you can have the the value of a column, right, be compared against all the possible values, right, that are listed here in this list, in this parentheses list, right, and you will only retrieve records that meet this criteria, that this column name is in. The possible values of column name are only the ones that are listed here in the in clause, right? So here's an example, right, that return to me all the people whose last name is either Boone or Garcia, right? If it's Boone or Garcia, right, it's going to be the record that I'm looking for. Okay. Some built-in functions that you can use in the where clause are the like that we saw earlier in the example. Like, and then the character comparison, patterns that you can check to see if a name matches something. You can extract dates, right? Where current date, and you can extract the year so that you can use it to compare against a value in your clause. right? You can also compare the current user if you're logged in. So for instance, this would allow me to retrieve, for me, I want to retrieve all the students that I'm teaching, all their grading, all their assignment, all their section. For me, I log in as myself, and the database would be able to retrieve data that is specific to me. If someone else logs in and uses the same query, they'll get a different set of results. Okay. All right, excellent. We got through the first SQL query set of slides. If you could, for Friday, right, read up on all the other subqueries and views and group by, right, so we can move further and get those under our belt. Okay. All right, folks, that's all I had for you today. I do have another class right afterwards. Is there any questions before we leave? All right, if not, thank you so much. Appreciate it. See you.
Thank you, Professor.
Thank you.
Thank you.
See you Friday. Take care. Bye-bye.